Hey friends, I was just taking a quick break from recording a couple other lessons. I went and watched the varsity girls basketball game. It was pretty good. They lost, but they had some really good plays and some defense. It was crazy good. Anyway, this is a lesson that just the honors advanced students have, not the regulars. So if you're going to talk to your friends from regulars and they said, what, lesson 6, 6, 6, 7? Well, this is the reason why. But one of the things that is very helpful for you to know how to apply stuff and looking for things is to know your properties of your quadrilaterals really well. And so you need to be able to fill in this chart for the correct quadrilaterals. So the cool thing is, I'm just going to do it really fast. And I'm not going to say tons and tons of detail here just because of time-wise. But this will help you solve for missing things that are congruent. So the very first thing is we have two pairs of parallel sides. Well, parallelograms all do that. So that means rectangles, rhombuses, and squares all work. Then the next one is only one pair of parallel sides. Well, that's going to be your trapezoid and your isosceles trapezoid. Now another one is that opposite sides are parallel. Now, that means both pairs of opposite sides, so that only works, once again, for parallelograms. Now, you can think of a trapezoid, only one pair. So let's actually write that down. Only one pair. If you had more than that, not going to be a trapezoid. And that goes the same thing, only one pair for an isosceles trapezoid, too. Then we have the fact that opposite angles are congruent. Well, that works for anything that's a parallelogram. So rectangles, rhombuses, squares. But now with a kite, remember we have only one pair that are going to be opposite angles that are congruent. It's the pair that's formed by the two different side lengths. The next one are consecutive angles are supplementary. Again, that only works every single time for anything that's a parallelogram. Then we have the diagonals bisect each other. Well, that, again, everything that's a parallelogram. Now, diagonals that are perpendicular. This is only for certain scenarios. We know that the rhombus's diagonals are perpendicular. That would make a square perpendicular, but we also learned that a kite was perpendicular. The next one is for congruent angles, which means that also means there were right angles, if that was the case. And so that would be for sure with a rectangle and a square. Otherwise, the other ones, not guaranteed, especially like any of them that are not parallelograms. Diagonals are congruent. Well, that has to be for a rectangle and a square, but also for an isosceles trapezoid. Remember, we had the theorem that says a trapezoid is isosceles if and only if its diagonals are congruent. For congruent sides, well, that's going to be a rhombus and a square. No parallel sides, that one gives us a kite. The diagonal bisects opposite pairs of angles, that's going to be on a rhombus, so that also works for a square. So this kind of gives you the idea of which properties work for which. Now, we are working with quadrilaterals in a coordinate plane. We want to prove things generically, so we're going to have to use a lot of formulas. First of all, you're going to have to know your midpoint formula, which is your average of your x's and the average of your y's. Your distance formula gives you the length between 2 points. x2 minus x1, that quantity squared, plus the quantity squared, quantity y2 minus y1 squared, all underneath the radical. You have your slope formula, y2 minus y1 over x2 minus x1. And I was just, I made a mistake earlier in notes because I wasn't paying attention to what my variables were, and I totally messed up my slope. I was so embarrassing. Remember, parallel line slopes are equal to each other. And remember that perpendicular line slopes are opposite reciprocals, which tell me if they're kites, rhombuses, or squares. Now, these can help us prove that what type of quadrilaterals we have and their properties. But first, one needs to be able to find the missing coordinates. All right, so how do we do this? Now, this you actually have on your quiz coming up. It's not that difficult, but you have to kind of naturally think of the different properties. And I'm not going to make stuff a lot different than what you see in your book. But the first thing it says, what's the property, what's the missing coordinates? And here we have a square. Remember, everything's the same size, same length. So the square, having one of its sides on an axis, makes it actually really easy. because I can use how high this point is to know how high this one is. So how high is that? Well, that's your y value. Well, what's your y coordinate going to be in this case? Well, that's going to be 3b, because I went up 3b. So here, I know my y coordinate is 3b. Now, what's going to be my x value? Well, x value goes straight up, and these are perpendicular because it's a square. Well, straight up is just a. So E is at A, 3b. That's its ordered pair. Now, how about I? Well, I, we should notice right away, the y is going to be at a 0. Notice I'm doing the y's first. For some reason, they click quicker in my head. But I also know that my x's don't change here for these 2 points. So that means 4a goes in. So those are my 2 ordered pairs. Now, how do we do this type of thing when it's not here? Like here we have the rectangle, and basically I just want you to remind you that's where the 2 diagonals would actually intersect, the way they drew this. My x's and my y's have to stay the same, but we have to consider up and above and below the x and y axis, so the left and the right. So here's an easy way of doing this. Now, because of where they have the axes drawn, and it's a rectangle, everything's going to be same size, same shape type of idea again. So like right here, I'm looking for the missing x coordinate. Well, did the x coordinate move here from this one? No. In fact, it just goes straight down. So that should be a negative 3a. So we know that would be the case. So that was missing. All right. Now, however, I'm missing the y coordinate here. Well, how much higher above the y axis is this one? 2b. Doesn't that have to be the same thing over here? Yeah. So that's going to be 2b. So that's the one that was missing right there. Now, how about going down below? If I went up 2b, how far do you have to go down? Right, a negative 2b. So my y coordinate's a negative 2b. Now, how far do I go over here? Well, I was over a negative 3a this way, so I have to be over a positive 3a. Or you can say, how far is that x over here? Well, that's 3a. So that's going to be m. This is the x coordinate for E. Negative 2b is the y coordinate, excuse me, not negative 2b, that's a positive 2b, is the y coordinate. And all we can do with how it's figured. Now, here's something we want to think about parallelograms. Remember, they're parallel, same distance, same length. But I want you to think in right triangles a little bit, because it helps us figure out how far things work. Okay? First of all, I am looking for the y coordinate here. Well, how do I find this? Well, if I drop straight down, that would be, x coordinate. If I drop straight down, I know that's a distance of b, so we know that's the case. But what's going to be our distance here? Well, I'm going to use the value that I can make a same looking right triangle right here. Okay, if this is at 0, how far do we have to go over to get to that a? A over. So how far do I have to go this way to get over? A more. Well, what's 3a plus a? Yeah, so that distance over was 4a. So that's 4a, b would be my ordered pair. Now, what's going to be my y coordinate? Well, where's it lying on? The x-axis, so that would be at 0. So it would be 3a, 0. So you kind of have to use your common sense with what you have there in order to get it. Now, we're going to go to the next page. We'll see how this goes.